Okay, so let's take a look at solving absolute value equations and inequalities here. What do we got going? Okay, let's remind ourselves, first of all, what absolute value is all about. Absolute value of x. Now, how do we write that? How do we write absolute value? I'm seeing this. Yeah, good. We get the bars, absolute value bars. So there's our symbol. And what does that mean? What's that? Let me have all iPhones, iPods, all that stuff away, please. Thanks. Okay. One way to interpret that is the distance. If I'm taking the absolute value of a number, that's its distance from 0 on the number line. Okay, so for example, we know it's always positive because distance is always positive, right? Always positive. If I ask you how far you ran, if you went for a run, you're telling me a distance, it would not make sense for you to say, oh, I went -3 miles. That doesn't make any sense. Maybe you ran backwards. I don't know. No, it's always positive. Distance is always positive. So the absolute value of -3 is 3, and we're all pretty familiar with that behavior. Right? You going back to when you've used absolute values in previous years, I'm sure you remember doing this kind of thing, where absolute value always makes negative numbers positive. What's it do to positive numbers? Stay the same, right? Because the answer has to always be positive. But one way to sort of visualize this, the absolute value of -3 would be its distance from 0 on a number line. Well, if we start at -3, and we want to figure out how far that is from 0, it's obviously 3 away from 0, and so that's why the absolute value of -3, we say, is 3. Okay, that's helpful to remember that. That's going to really help us today if we can think of absolute value in that way, as a distance from 0. It'll help us with some later things that otherwise could be a little bit confusing. So what about something like this then? What if we're faced with an absolute value equation? Absolute value of x equals 5. Well, what we're really asking for then are all the values of x on a number line that are exactly 5 from 0. What would those be? -5 and 5. So we can think of, if we think of it in terms of the distance from 0, it's pretty obvious that it's -5 and 5. Even if we don't, we can still sort of power through this and see why those answers have to be -5. Think of it from a strictly algebra point of view. If we know that the job of absolute value is to make something positive, what could it have started out as? It could have started out already as positive. And what positive number, absolute value of what positive number is 5? Well, 5, right? But it could have also started off as being negative. And when we take the absolute value, it would make it positive in the end, right? So if x were negative, if that number were negative, what's the only number that would work? 5, as you already told me, right? So either it's 5 or -5. And I know this is, you're probably wondering why I'm spending so much time on that simple one, but that same concept is going to help us out when we do a little bit harder problems, like this, okay? Now, if we want to solve something in this form, so we're going to do problems where the a and the b and the c are actually numbers, right? And we're going to get an answer that way. But as we're doing this, I want you to think about that same idea that whatever's inside the absolute values is just a distance from 0 on the number line, okay? So to do this, we're going to set up two equations, okay? We're either going to assume that the number in the absolute values is positive or it's negative, and we'll treat both cases. Okay, and whenever we do stuff like this, when we do algebra involving absolute values, there's a step that I'm going to say this over and over again. The first thing is we always have to make sure that we get the absolute value by itself on one side of the equation, and that might involve an algebra step or two. So let's take a look at this one then. Okay, now, two ways to think about this. We can think about whatever's behind my hand, and we're not going to worry about what it is. It's just going to end up being some number, right? We want the distance. Well, we want to know what that number is so that the distance from that number to 0 on a number line is 15. So what could that be then? What could the number be that's behind my hand if its distance from 0 has to be 15 on the number line? Don't worry about it. It looks complicated, but don't worry about that. Pretend you don't even know that there's x's and 6's and 3's. If I had just said the absolute value of what is 15, what two places on a number line are 15 away from 0? 15 and negative 15, right? Another way of thinking about that is, we know we can start off either positive or negative. If the absolute value is 15, then obviously the two values that we would have to consider that could be in the absolute values would either be 15 itself or its opposite, negative 15, right? So then if we want to solve this as an equation, now that we actually see that what's in the absolute values, what's behind my hand, is an algebra expression. It's 6x minus 3. Well, we know that value of 6x minus 3 has to either be 15 if it starts out positive, or negative 15 if it starts out negative, right? Does that make sense? So just making that first step there, we're gonna turn this absolute value equation, we're gonna essentially trade it in for two simple normal equations like the kind we've always dealt with, okay? The way we do that is by just setting the argument of the absolute value. That's a fancy math terminology for just saying whatever's inside the absolute value bars either has to equal whatever the solution is on the right side of the equation, the constant. It's either that or its opposite. Okay? Questions on that? Does that make sense? So once we're faced with an absolute value equation like this, that's our first step. Now what do? Just solve them. Yeah. Now we've gotten rid of the absolute value weirdness and we just do regular algebra, right? Okay? And in both cases, what are the two steps we would do to get the x's by themselves? Add 3 and then divide by 6. And I'm going to get different answers in both cases, but the steps are the same. When I add 3, I get 18 on the left and the left equation. And on the right equation, I get negative 12 on the other side. Divide by 6, and I get 3 or negative 2. Okay? So those are the two possible values that x could have been. And of course, we could check by just plugging those into the original absolute value equation to see if it works. If I put in 3, I'm going to get 6 times x is 18 minus 3 is 15, and the absolute value of 15 is 15, sure. Okay. If I choose negative 2, 6 times negative 2 is negative 12. Negative 12 minus 3 is negative 15, and the absolute value of negative 15 is once again positive 15. So it worked, right? Okay, let's try another one. Now, what do I have to do here? What do I have to do first? What do you think? Yes, sir.
Why don't you add 3?
Good. Okay, the first thing I've got to do is I've got to add 3 to the other side. Very good. Got to do that. Okay, if I add 3 to the other side, then I'm going to get the absolute value by itself. That's always, remember we said that's our first goal. Now we've got sort of a new problem that's easier to deal with. Now we've got a problem where I've got the absolute value of whatever's behind my hand is 11. So what are the two values that could be in the absolute value? And what are the two numbers that could be represented by that 2x plus 7? Either it could equal 11, because the absolute value of 11 is 11, or it could equal negative 11. So we'll split that into two parts and solve, just like before, right? We set whatever's inside the absolute value, we set equal to 11 or negative 11 and just solve, and I get two different answers, 2 or negative 9, right? Okay, so what about inequalities? Okay, now inequalities, the good news is it's the same kind of stuff, okay? But we have to keep track of which kind of inequality gives us which kind of result. There are two possibilities. We're going to look at expressions like in case number 1 here, where we have the absolute value of some x stuff is less than a number, or we could have a case where we're taking the absolute value of some x stuff is greater than a number. Okay, we got to know what to do with both of those. Now think about it this way. If the stuff inside the absolute value bars represents the distance from 0, right? Then if I want to know what are the values inside the absolute value bars that are less than that distance from 0, what's that going to look like on a number line? And somehow this stupid thing is not working again, and I can't draw on the board. I got to get this thing fixed. Because I wanted to be able to draw a number line there, but I can't. Let me ask you this. If I want the values, the numbers inside the absolute value bar that are less than C away from 0, what's that going to look like on a number line? Is that going to look like the values that are between C and negative C, or outside of that? Let me say that in a different way. Let's go back and look at this quick example here. We found out that, okay, in this case right here, here's what I want to look at. Okay, if I had the absolute value of something equals 5, then we said the points on the number line were going to be at -5 or +5, right? Now, what if I wanted the values that were less than 5 away from 0? Is that going to put them closer to 0 or further from 0 than 5? If the distance to 0 is less than 5, are those values going to be closer to 0 on the number line or further apart? They'll be closer, aren't they? Right? Like, for example, what's a value that would work? Like 4 would work, wouldn't it? If this were a less than sign instead of an equals, which I can't draw once again because this thing's broken, but pretend it is, then is 4 less than 5? That would work, wouldn't it? Right? And so I'm talking about the values that are closer to 0. So if I advance ahead here real quick, doesn't it make sense then that when I see an absolute value of some stuff is less than a number, that's going to be an and kind of a problem, where I'm going to graph on the number line, I'm going to fill in all the points between the endpoints, right? It's like an and, so I'm graphing the parts between. If it's something like this, on the other hand, like case number 2, where I have the absolute value of some x stuff is greater than c, that's telling me that the distance from 0 is more than c. Doesn't that mean I could either go out far to the left in the negative direction or far to the right in the positive direction to get big values that are far away from 0? So that's going to become an or problem. And I'm going to graph outwards like the oars on a boat, like we said the other day, right? Okay, so I'm going to trade this one in for an or compound inequality. In case number 1, I'm going to trade the absolute value inequality for a regular and inequality. Okay, and look what we get then. So I'm gonna pinch whatever's inside the absolute value bars. If I'm going to make this a compound and inequality, it goes in the middle, right? And it's pinched between a lower value of negative c and an upper value of positive c. Okay, but if the inequality sign looks like this, if I'm saying the absolute value of some x stuff is bigger than c, so it's further away, then I got two sort of extreme possibilities. Either the x stuff is more than c in the positive direction, so it's greater than c, or it's more than c in the negative direction, so it's less than negative c, further to the left than negative c. Let's try an example and I think it gets clearer. So what about this guy here? If I have the absolute value of some stuff is less than or equal to 21. So we're saying that the distance to 0 is less than 21, so it's an and problem, right? Whatever used to be in the middle of the inequality, whatever used to be in the absolute value bars, ends up in the middle of the and inequality, pinched between negative 21 and positive 21, right? And now I have to just go find out what values of x make that happen by solving for x algebraically. But that's the stuff that we did in 1/6 that we talked about last week on Thursday, right? So what do I do if I want to get the x by itself in this inequality? Okay, got to add 9 everywhere, right? So I add 9 to all parts. Negative 21 plus 9 is negative 12. 21 plus 9 is 30. Good. Now how do I get rid of the 4? Divide by 4. Now I'm dividing by a positive, so I don't have to flip any inequality signs around, right? So if I divide everything by 4, I'm going to get negative 12 divided by 4 is negative 3. 30 divided by 4 is 15 halves. Turns it works out to be 30 over 4 reduces to 15 over 2. So 7.5 if we made it a decimal, right? So then if I were to graph this, look what I've got. I'm gonna pinch the values in between negative 3 and positive 7.5. Now, because I'm actually including those endpoints, my original inequality is a less than or equal to, we're going to fill in the dots there, right? The less than part is, though, is telling us we have to take also all the values in between. Okay? Right? So the trick here, the part that's different, and I don't know how many people have actually done 1-6, and when you do 1-6, you'll get to practice doing this stuff. But the new part in 1-7 is that we're trading the absolute value inequality, which is weird, for a regular inequality, compound inequality. And once we make that trade, then we can just do normal algebra on it. Okay? Now what about this guy? Notice here that I've got an absolute value is greater than or equal to a number. So this is going to be an OR. I'm going to trade the absolute value inequality for an OR one. But what do I have to do first? Got to subtract 3. I've got to get the absolute value by itself. So once I subtract 3 from both sides, now remember the distance from 0 is going to be extreme. It's going to be bigger than 8 in the positive or negative direction. So it becomes an OR situation, right? What am I going to, so what's one of those OR inequalities look like? 3x minus 2 could be what? What if it's really extreme in the positive direction? What if the distance is bigger than 8 in the positive direction? Then 3x minus 2 is what? Is, well, we'll get there. Yeah, we're not gonna jump ahead, but whatever's inside the absolute values is going to be greater than or equal to positive 8, right? That's one possibility. So it's greater than or equal to positive 8, but it could also be negative. It could be very negative. It could be pushed out very far in the negative direction. So whatever's inside the absolute value bars could also be left of or less than or equal to negative 8. Those are our two extreme, right? Does that make sense? It's either got to be very far to the right, bigger than positive 8, or very far to the left, less than negative 8. Less than meaning left of on a number line. So if we add 2 to both sides, you know, the 3x minus 2 is greater than or equal to 8. If I add 2, I get 10 on the right side. I could divide by 3 and get x is greater than or equal to 10/3. So that's part of my answer. If I look at the other situation, if I add 2 to negative 8, I get negative 6. Divide by 3 and I get x is less than or equal to negative 2. So let's look at the graph. I'm going to have a solid endpoint at negative 2 and a solid endpoint at positive 10/3, so 3 1/3, right? And then I'm going to, it's oars on a boat, so I'm going to shade out to the sides, right? Makes sense because originally our distance, we wanted our distance from 0 to be greater than or equal to 8, so further away. Okay? Get the idea?
Yeah.
Okay? Here, I want to be able to write. This is really driving me nuts that I can't write on these things. Okay, so let's try one just for practice here. What if we got this? What if I got the absolute value of 2x plus 3?
Yes.
Okay, let's try that one. Okay, take a look, please. So what about this one here? Before we do anything, what do we want to do?
So plus
solve
four.
Okay, we got to add 4 to both sides. We got to get the absolute value by itself, right?
Yes.
So if I add 4 to both sides,
11.
okay, what do we get? On this side we get 11, on this side the 4's cancel, and I get the absolute value of 2x plus 3 is less than 11. Now think about this. That's like saying the distance from 0 is less than 11. Let's take a look at a number line real quick. Now that I can draw, I think I can maybe make this a little clearer. So just, what's that gonna look like? If that's 0, and I want all the points whose distance from 0 is less than 11. Well, what points have a distance from 0 that is equal to 11? Negative 11 and positive 11, right? So if I want the points whose distance is less than 11 from 0, isn't that gonna be all these other points in here?
Yeah.
Right? So aren't I just gonna do this? Right? So we can see right away that this is gonna be an and kind of an inequality, isn't it? Because it means we're taking values in between. But we're not actually looking for what's the number behind my hand, because that's obvious. That's gonna be all the numbers, or the numbers. Those are the numbers that are pinched between negative 11 and 11. We're trying to find x, which is just a part of that number, right? So this is where we have to do the algebra. Now, what kind of a trade do we make? If the absolute value of something is less than 11, how do we rewrite this absolute value inequality? Good. Okay, so all the stuff in the middle, all that stuff, 2x plus 3 has to be greater than negative 11, right? Whatever's going to build that number has to be greater than negative 11 and less than positive 11, right? And now we can just shift gears and do the algebra, right? So what are the 2 steps we go through to get the x by itself? Subtract 3. And that's going to give us 2x in the middle, right? Negative 11 minus 3 is?
Negative 14.
Negative 14, good. And 11 minus 3?
8.
8, good. And we've got those symbols. Now what?
Divide by 2.
Divide by 2. And we end up with what? X, negative 7, and 4. And there's our answer. How about that?
That's cool.
Okay. I mean, whether it's cool or not, can we? Is it a? What we're looking for is a systematic approach to this. If we know how to approach a problem like this, then the algebra is going to be different each time. But that's, I mean, we know what the steps are. We can go through. Okay, last one. How about this? What if I have the absolute value of? How about 2 times? We'll make a really hard one, harder than the ones even. Absolute, or 2 times the absolute value of 3x minus 1 minus 7 is greater than what? It's greater than
1.
37.
3. 7.
1. Okay. So now what? Okay, what's the first thing I got to do?
Multiply by 2.
Okay, hang on.
Divide by 2.
Okay, yeah. Do I multiply by 2? You could, but what did we say about with an absolute value equation? What's the first thing we want to always do to the absolute value?
Get rid of it.
We want it. Well, we're going to get rid of it. We got to get it by itself on one side of the equation or inequality. So how do I get that by itself? If it's being multiplied by 2.
7.
Okay, first thing I got to add 7 to both sides because I'm isolating something. I'm isolating that. I'm isolating this whole absolute value expression. So to get it by itself, I reverse order of operations. I'm going to add 7 to both sides. Okay, and that's going to, those cancel, right? And then I get 8 on this side, and over here I've got 2 times the absolute value of 3x minus 1. But I still got to get this thing by itself. I'm not quite there.
Divide by 2.
Good, so then I divide by 2. Divide both sides by 2. If I do that,
4.
those cancel, right?
4.
And I get 4 over here. And now I've got my absolute value of 3x minus 1 is greater than 4, right? Okay, now if I'm saying the absolute value of something, so this just represents a number. If the absolute value of something is greater than 4, that means I want all the numbers that are further away than 4, that are more than 4 away from 0. Right? So if I were to look at it that way on a number line, there's 0, The two numbers that are gonna be exactly 4 away from 0 are 4 and -4. If I want the values that are further away, is that gonna look like this? So we can see that we're gonna have an OR inequality for our answer, aren't we? So we're gonna make our trade that whatever's inside the absolute values has to be what? Well, it's gonna be less than -4, right? So whatever's in that blue bubble is gonna be less than -4, or whatever's in the blue bubble is gonna be greater than +4. Well, what's in there? 3x minus 1. So now we just do the math, right? In both cases, what do I do to get the x by itself?
Plus 1 divided by.
Good, add 1. So I get 3x is less than
So -3.
-3. So x is less than
Negative.
-1. There's half my answer. Or if I add 1 here, I get 3x is greater than 5. Divide by 3,
X is
greater than.
1.
So as a decimal, it'd be 1.6 repeating, but we will leave it as a fraction, 5/3. So there's my answers. Okay, make sense? I mean, it probably will kind of make sense now. When you go to do the assignment, you might forget a little bit of this, but here's the thing in math. If you could get it once in class, re-getting it is no big deal. If you can get to that point where you get it once, your brain has created some structure. You can always get back to it. It's like riding a bike. Once you learn how to do it, you can always get back on and figure it out. Okay, so, see how much time we have here. 40.